Magnets are one of the coolest things ever that exists in our universe. For example, you can utilize them to pin things to your fridge, you can pick up metallic objects without even touching them using magnets, and when you have a bunch of magnets, you can create some attractive artwork. But how exactly do magnets even work? Well, as most of you watching this know, all magnets contain a magnetic field, which is the space surrounding the magnet in which magnetic force is exerted. The magnetic field is what attracts and repels magnetic materials and other magnets. Now, what would create a magnetic field? Well, let's say we had a wire and an electric current flows through the wire. The current creates a magnetic field around the wire. The current itself is made up of moving electrons, and the movement of electrons create a magnetic field. However, if we truly want to know how a magnet works, we're going to have to take a closer look. We're going to have to zoom into the quantum realm. As we all know, electrons orbit around the nucleus of the atom on specific energy levels called electron shells. Within each electron shells exist subshells. Each subshell can hold up to 2 electrons which have different spins, which is nothing but a fancy term for the inherent angular momentum of an electron. Usually in a pair of electrons found in a subshell, one electron has a spin of up and the other electron has a spin of down. The spin of the electron, which is believed to create a small magnetic field, which combined with the other small magnetic fields from other electrons, can create one big magnetic field which is powerful enough to influence objects. Now, when talking about magnets from a quantum mechanical level, I can obviously go into much more detail, but for the sake of simplicity and time, let's save that for another day. On a final note, before I conclude today's lesson, let me just go ahead and state there are 6 different forms of magnetic forces that we know of. The first is diamagnetism. Diamagnetism, simply put, is when an object is repelled from both poles of a magnet and lines up across the magnetic field. This form of magnetism is extremely weak and can be easily overpowered by other forms of magnetism. Next up, we have paramagnetism. Simply put, objects that are considered paramagnetic are weakly attracted by strong magnetic fields. Then we have ferromagnetism. Ferromagnets are the type of magnets which are associated with iron, cobalt, and nickel attraction. Next on the list is antiferromagnetism. In antiferromagnetic materials, the magnetism from one set of magnetic atoms positioned in one direction is cancelled out by a set of magnetic atoms facing the opposite direction. Also, antiferromagnetic materials don't seem to respond to external magnetic fields in very low temperatures. Next up, we have ferrimagnetism. In ferrimagnetic objects, the magnetic fields of individual atoms spontaneously align themselves. Some atoms align themselves in a parallel position, as in ferromagnetism, and others align themselves in anti-parallel positions, such as in antiferromagnetism. Last but not least, we have superparamagnetism. Superparamagnetism is the seemingly paramagnetic behavior of objects which are made up of tiny, weakly interacting ferromagnetic and/or ferrimagnetic particles. There are also different classes of magnets, such as permanent magnets or magnets that retain magnetism after being magnetized. Then we have temporary magnets, or magnets which can't function in the absence of a magnetic field. Next up on the list are electromagnets, which are devices that can create a magnetic field through the application of electricity. And finally, we have superconductors, which are magnets that can conduct electricity and transport electrons between atoms with no resistance. I hope you learned something from today's lesson. That concludes our topic for today, and I hope this information sticks to your head.